Hello again everyone, welcome back with me Nathan. In this video, I want to introduce you to GPT 4.1, which is cheaper, faster, and better when compared to GPT 4.0 and GPT 4.0 mini models in almost every single way. So just last week, OpenAI released a new AI model called GPT 4.1, but with a catch. It's only available through their API, meaning you can only access it by making a network request in code. You won't see it if you log into chatgpt.com. It's not available for direct use there. This GPT 4.1 comes in 3 different types. First, there's the GPT 4.1 regular version. Then, there is a lighter model called GPT 4.1 mini, which is significantly cheaper and faster. And then lastly, we have the cheapest, smallest, and most efficient model called GPT 4.1 Nano. As I said before, these new models outperform GPT 4.0 and GPT 4.0 mini across the board, with major gains in coding, instruction following, and long context performance. Yet the most significant upgrade comes in the model context windows. The 4.1 models now support up to 1 million tokens of context and actually use that context very well. These improved context should help the AI remember and reason across massive amounts of information, especially when it encounters huge code bases. I'm very certain that this is done to keep up with the Gemini 2.5 Pro model, which also has 1 million contexts, so props to Google for forcing the competitors to adapt. The knowledge cutoff is June 2024. Not bad, though I do wish it went a bit further, like December 2024, but that's okay. Now here's the technical detail. In regards to coding, the GPT 4.1 crushes it on the SWE bench verify test with a 54.6%, which is a 21% approximate increase in terms of its improvement over the GPT 4 Omni and 27% better than GPT 4.5, which is awesome. Next, the instruction following. On Scale's multi-challenge benchmark, a measure of instruction following ability, GPT 4.1 scores 38.3%, a 10.5% increase over GPT 4.0. Yup, pretty sure this will be useful in agent mode. And then on long context, on video MME, a benchmark for multimodal long context understanding, GPT 4.1 sets a new state-of-the-art result, scoring 72% on the long no subtitles category, a 6.7% improvement over GPT 4.0. Next, OpenAI specifically say they trained this model to have real-world utility. Close collaboration and partnership with the developer community enabled us to optimize these models for the tasks that matter most to their applications. Well, there you go. It's clear that 4.1 is specifically created for programmers and developers in mind. Now here's a simple graph provided by OpenAI to illustrate the improvements in 4.1 models. Here, you can see that on the y-axis, we have intelligence on multilingual MMLU, which stands for Massive Multitask Language Understanding. Then on the x-axis, we have latency, which is the speed at which the models process and send a response back. At a glance, we can see that GPT 4.1 is smarter than GPT 4.0 while having about the same speed. Then, we have GPT 4.1 Nano, which has the lowest intelligence among the listed models, but it makes up with its speed. Now, keep in mind that Nano is the smallest model. It's also the first time that OpenAI released a Nano model, so it's only natural that it's below 4.0 mini. Finally, the most significant gain in this graph is the 4.1 mini. Here, you can see the intelligence gain is very significant when compared to 4.0 mini. It almost matched the 4.0 model right here, but the latency is only around half of 4.0. And keep in mind that all 4.1 models has a 1 million context window, so these are all very incredible gains on paper. Next, GPT 4.1 mini is a significant leap in small model performance. Even beating GPT 4.0 in many benchmarks, it matches or exceeds GPT 4.0 in intelligence evolves, while reducing latency by nearly half and reducing cost by 83%. Yeah, as I said, it's 4.1 mini that's getting the spotlight here, and 4.1 Nano is the fastest and cheapest, ideal for tasks like classification or auto-completion. I'm very certain that 4.1 Nano is designed to power code completion. But again, these improvements in instructions following reliability and long context comprehension also make the GPT 4.1 models considerably more effective at powering agents or systems that can independently accomplish tasks on behalf of users. Now, for those of you who don't know, OpenAI has an exclusive deal with Microsoft, which owns GitHub, and this is why GitHub Copilot can have unlimited agent mode and chats with GPT-4o in their Pro plan. I do hope that in the future, Copilot can have unlimited agent mode and chat with GPT 4.1. With GPT 4.1 for the agent mode, 4.1 Nano for the code completion here, the 1 million context window coupled with the increased performance will be a huge gain for Copilot users. Anyway, back to the post. Note that GPT 4.1 will be only available via the API. In ChatGPT, many of the improvements in instruction following, coding, and intelligence have been gradually incorporated into the latest version of GPT-4o, and we will continue to incorporate more with future releases. I'm a little bit confused with this one. So you have GPT-4o in chatgpt.com, but it's actually a GPT 4.1. So isn't that means we actually have 4.1 in ChatGPT? How does it work over here? Anyway, another benefit of the 4.1 models is the pricing. The base model is $2 for a million input tokens and $8 for the output. Mini is 40 cents for input and 1.60 for output. And the Nano is actually 10 cents per input and 40 cents per output. Nano is actually OpenAI's cheapest model available right now. These models are cheaper when compared to Cloud 3.7 and Gemini 2.5 Pro APIs, as you can see on the screen here. The rest of these blog posts explore the 4.1 models in more detail. I will leave these blog posts in the description. You can read the rest if you want to. But for now, I want to stop right here and start testing GPT 4.1 and compare it to Gemini 2.5 Pro, which is still the king of coding according to LM Arena. Let's get to it. Now, I'm going to test the models using a handful of different coding tasks. Both models have long context window, so they are going to be really useful in various sorts of complex coding tasks. There are 4 tasks that I will give to the models, and I will see if they can complete the task and implement all the requirements specified on the prompt. The first task will be to build a procedural city generator using the HTML5 Canvas API. It should draw a top-down view of a city with randomly generated elements such as streets, buildings, parks, and intersections. Include simple animations like cars moving along roads or lights turning on in buildings. The layout should regenerate with each refresh, but follow consistent logic, e.g. roads intersect cleanly and parks don't overlap buildings. Output size should be 1000 x 600 pixels. Alright, to test the Gemini model, go straight to gemini.google.com, select the Gemini 2.5 Pro model, paste the prompt, then click on the Canvas button and fire away. While Gemini is working, let's request the same prompt to GPT 4.1. To access GPT 4.1, you can use GitHub Copilot in VS Code, so open VS Code and launch the Copilot chat window. You will have to register an account with GitHub first if you haven't already. It's easy and free. Here, I will give the same prompt and I will try to run in agent mode. Make sure that the model is set to GPT 4.1. Then paste the prompt. All is ready, so hit the submit button. Okay, so Copilot agent mode actually fails when using 4.1. It just stopped running after showing this output, so I will open a new chat, set the mode to Ask, and run the prompt again. Strangely enough, GPT 4.1 actually asked it to generate a workspace here and actually create files and write code, which it shouldn't be able to do under the Ask mode. Okay, now GPT 4.1 has stopped. Now let's try to run this index.html file. Nothing is showing but this background. I think there's an error over here. Yep, there is. I can check on this error, but I won't do it for now. I just want to try one-shot the coding task, so I consider this as a fail. Next, here's the output from Gemini 2.5 Pro. Now this is very cool. So the Gemini is able to build a map according to the specs, with moving cars and building lights, parks, and streets. Now let's try to refresh this preview. And yep, the city is randomly generated, the buildings are moved around. Very cool. When using Gemini Canvas, the code will automatically show a preview. You can switch to the code view here. Okay, so the result is that GPT 4.1 failed, while Gemini 2.5 Pro passed the first test. Next, we're going to have the 2 models work on a front-end development task. They need to create a simple but functional Kanban board, like Trello, using only React without backend, And users should be able to add columns, create tasks, drag tasks between columns, and rename or delete everything. Keep the entire app in a single JS file and persist state using local storage. Let's let them work again. I will pause the video here and skip ahead to the result. Alright, now we're going to see which generation is better. So here's the app generated by GPT 4.1. The CSS styling is off, as you can see here. The text is too white. But let's try to test the functionalities. First, create a new column. Okay, it's working. Click and drag a task to the other board. Then bring it back. Click on the task. It shows an input for editing, good. Name this as sample task. Click OK. Then add a new task. Name this as task 1. It's working good. Now add a new column. Add another column. Delete a column. Delete again. Okay, so the functionality of the app is great, even though the UI is off. And here's the app generated by Gemini 2.5 Pro. The CSS styling in this app is awesome. As you can see, the color is beautiful and everything is just pleasing to the eyes. Now let's try the functionalities. Add a new column first. Good. Now add a task. Test Gemini versus GPT. Save the task. Now drag the task. It's working. Drag again. Next, delete the task. Now this is not working. I click on the trash can icon and nothing shows. How about the edit icon? Okay, the task is editable, it seems. Move the task again. It's still working, so definitely the task is not deleted. Try to delete the board. Okay, it's not working too. Let's try to change the task name here. Okay, the task name doesn't change either. So for the Gemini app, the UI is great, but some functionalities are missing. Alright, so GPT 4.1 actually got all the requirements correct, while Gemini 2.5 Pro missed some of the requirements, such as editing and deleting a task. Here, I'm going to mark GPT as pass while Gemini fail, even though Gemini has more beautiful UI. The task is not about creating the best UI, but fulfilling the requirements as specified in the prompt. For the next task, we're asking the models to build a command line interface app using Python that lets the user track income and expenses, support commands to add, list, edit, and delete transactions, store data in a JSON file, allow filtering by date category and generate a summary report, include simple input validation. Okay, let the models work on the task. I will skip ahead to the results. Right, so GPT 4.1 again generated a full workspace while in apps mode. But when I try to run the app, it shows an error, so I think this is a fail. As for Gemini, it generated Python code that can be exported to Google Colab, so I'm going to do just that. Open the Colab page. Now that we have the app in Colab, let's run it. Nothing happened. Let's scroll down. I think there's an error here. And yep, we also have an error. So the result is that both GPT and Gemini failed this task. I think the task is just too hard to complete in one prompt. I need to write an easier task to task these models. So now we have the final task, which is to create an in-browser music visualizer that responds to audio input, either from microphone or uploaded file. Use the Web Audio API and draw dynamic shapes on a canvas element that react to frequency band and include multiple visualizer modes that the user can switch between. Again, we will copy this prompt and paste it to both Gemini and then to GPT 4.1. Okay, I will skip ahead to the result.
A few moments later.
Alright, so GPT 4.1 also failed this test because the generated app can't be executed. There is an error here. On the other hand, Gemini seems to successfully generate the visualizer, but the preview window here is too small, so let's view the code and copy it. Back in VS Code, create an index.html file, then paste the Gemini code here. Run the HTML file in the browser, and here we can see the full UI. So let's select a file to test this visualizer. I will pick an MP3 music file. And yep, this is working. Let's switch the visualizer. Okay. Okay, it all works. Cool. So Gemini actually passed the final task while GPT failed. Overall, it's obvious now that Gemini 2.5 Pro will be the winner, but GPT 4.1 is not so bad, as it was able to create a fully working Kanban board app, although the text styling is wrong. After all, Gemini 2.5 Pro is a reasoning model, while GPT 4.1 is not. While the price is indeed cheaper, GPT 4.1 can't reason, which means its ability to solve problems can't be as good as reasoning models. I mean, it's just not logically possible, right? And that brings us to the end of the video. So, what do you think about the new GPT 4.1 models? Personally, I think it's pretty average, but maybe I'm just comparing it wrong, or the tests that I gave maybe were too hard. I hope you all enjoyed today's video and get some value out of it. Let me know your thoughts or questions in the comments. I will join the conversation and reply as often as I can. If you're new to the channel, Code with Nathan is a channel dedicated to simplify complex tech topics so that you can master them easily. So make sure you subscribe if that's something you find interesting or useful. Make sure you like this video, turn on the notification bell, all the good stuff as it helps this channel to grow. With that being said, thanks again for watching until the end. I hope you have a wonderful day and I will see you in other videos. Bye bye!